Earth's climate. This is part 4, and as you've learned before, carbon dioxide is an important factor in the determination of the variables that go into making up the temperature of the lower atmosphere. And all this effort that we're talking about, stop burning fossil fuel, is not going to remove what's already in the atmosphere. It'll just slow down how much we're adding to the atmosphere. So if we really want to do something about the rising oceans and the Pacific Island nations that are only a couple of feet above current sea level, if we're serious about doing something about that, we need to remove carbon dioxide from the atmosphere. And I think the way to do that is the mechanism that led to 13 ice ages in the last million years, and that is the oceanic sink for carbon dioxide, of which the limiting element is dissolved iron. Blaine and company in 2007 reported on the finding that had been seen by satellites of a bloom of phytoplankton in the South Pacific. And he and his 45 authors, which are listed there in the fine print, reported in detail how the natural iron was utilized by phytoplankton. And these are the affiliations of some of the authors of this paper, and they're all of prestigious universities, many of them in France, but some in Australia and New Zealand. So there's, I think, reason to pay attention to this report that they wrote. So this is the location where they've seen by satellite 45,000 square kilometers of chlorophyll bloom annually from November to February. And that plateau is located 50 degrees, 38 minutes south, and 72 degrees, 5 minutes east. And that's what makes up the 45,000 square kilometers area where the bloom is observed. And they didn't put any iron in the ocean. It was all supplied from the upwelling of deep ocean waters. And with the phytoplankton depleting the iron at the surface down to 200 meters, the iron is down to 0.09 nanomolar dissolved iron. And it gets down to that lower level because that's below which the phytoplankton can remove iron. If the iron's below that concentration, it can't utilize it. And silicic acid was low, and that's SiO4, OH4. It was only 1.5 micromolar, but that was sufficient to supply the phytoplankton. And the nitrate was normal for this region at 23 micromolar. And one of the innovations that this paper utilized to follow the removal of carbon dioxide from the atmosphere to the ocean bottom was that they used the uranium-238 content of the oceans, which got a radioactive half-life of 4.5 billion years in its decay to thorium-234, which has got a half-life of 24 days with the emission of 63,000 volt electrons, beta minus. In the deep ocean waters, the thorium content causes Geiger counter readings at 2.5 counts per minute per liter, but within 200 meters of the ocean surface, the POC, which is particulate organic carbon, depletes the thorium content to less than 1/2 count per liter. And that is how they follow the fact that the phytoplankton, in addition to removing the carbon from the atmosphere, it takes it to the ocean bottom. So when those three nutrients are present in sufficient quantities, the phytoplankton, when it utilizes 1 gram of iron, it takes 500,000 grams of carbon to the ocean bottom. And at that rate of removal, I estimate that if we can maintain those three elements in any area of the ocean, which there's a way to do that that's practical, and in the presence of that, all we'd have to do is add 8,000 tons of iron annually to remove all the carbon dioxide produced by fossil fuel combustion worldwide. And this augmenting of the oceanic sink for carbon dioxide is what's responsible for the 13 ice ages, that each one of them lasted 100,000 years in the last 1,000,000 years on Earth. So I don't think we need to quarrel about the effectiveness of the oceanic sink for influencing the carbon dioxide content of the atmosphere. So what are our options for tomorrow? I suggest that we remove carbon dioxide by fertilization of the pelagic seas, very likely having to add each of the three components listed there. And secondly, I suggest we need to curb population growth, which you realize exceeded 7 billion in the beginning of 2012. And then, of course, we always got option C, continue to do nothing like we've been doing, and then just wait for whatever ensuing disaster occurs. And thank you for listening. And I appreciate your attention.